location?
Hi, I'm John McMaster here in my Silicon Valley lab. Yusuf, I hear you've been doing a bit of 3D printing recently.
Yeah, I printed a bunch of stuff like on my brand new printer. Last week we had on the episode. Oops, sorry. There we go. Playing. Last week I printed a little adapter for my DSLR to make it allow it to take macro photographs. And this week I printed you a part for your microscope.
Yes, did you know what kind of the problem that I was trying to solve there?
Yeah, you told me. So you have a digital camera or a digital sensor that's connected to your microscope that allows you to take pictures of what it's seeing. And because they're high quality optics and very sensitive, they do have certain optical aberrations, which are usually corrected on the optical eyepieces, but not on the camera inlet. And you wanted to adjust it to minimize that.
Yeah, maybe what I can do is I can start by panning over to the microscope, point out a few of the components, and maybe we could focus a little bit on the observed problems. And then we could talk a little bit more about the theory on how to correct them. Does that sound good?
Sounds good. Let's go.
Okay. So I'm going to pan over then. So here's my microscope, and I think you can see kind of a rough overview of it there. And I'll just point a little bit over here. So samples are down here. Light comes in from over here. It bounces through basically some light filters over here. Some of the light then bounces down through this objective, then bounces back up. It goes through a beam splitter in this area right here. Some of that light goes to a camera here, and some of it goes through the eyepieces here. Okay, so that's a very quick level overview. And this is a so-called metallurgical microscope, which is a little bit different than your high school biology microscope. Now, one of the things that you were alluding to a bit, and let's see if I can grab this over here. These are more or less the objectives that were intended to be used with these microscope, which you can see a little bit there. And you'll notice they're a little bit different shape than these objectives over here, right? What's kind of the big obvious thing that's different between these?
I guess some are longer and others are shorter.
That's right. And the main thing that these objectives are for, the reason why these are so big, is these are so-called long working distance objectives. But also, as you alluded to, there's also one other big difference between these. These are made by Olympus, and these are made by Meditoyo. And what was that comment you had earlier about the way that the optical corrections are done?
So the objectives are paired with the ones at the eyepiece to avoid the aberrations, right? Or to negate the aberrations.
That's right. And part of the issue is, if I can get these maybe a little better in frame, kind of, okay. Yeah. So the issue is it's very difficult to do all of the corrections in the objective here. So a lot of times what they'll do is, to save a little bit of cost and just generally better image quality, they'll do some of the corrections here in this lens. Now that also means that if you have a camera on here, you also need a special correcting relay lens here as well. So everything has to be paired. So whatever you start with down here, it has to be paired with the correct optics over here. Now, as a result of this, if you try to get like a DSLR on these scopes, you need the special relay lens called an NFK like 1.67 or something like that. Now, here's a funny piece of trivia. I have one that's like an NFK like 2.5 or something like that, and that goes for like $40 on eBay. But the one that's designed for DSLRs, because there's so many people that want to use these microscopes, guess how much that 1.67 times goes on eBay, given the other one's $40.
$400?
Oh, way higher than that. In fact,
$800?
Yeah, close to that, like $800, $1,000. And that's because I think there's just a lot of people maybe want to use the stock parts on this. They have this microscope, and maybe they're not aware of some of the alternatives for this. So where this project also kind of started out was me researching what was the proper solution to correct all these things and line them up. And after finding out that that piece was so rare, trying to understand what could I do instead. Now, circling back a bit, so we know what, in theory, you're supposed to get this official Olympus part that's really rare. But it circles back to another thing, though. For most imaging, I am not using the official Olympus objectives, right? I'm actually using these long working distance objectives. So the corrections that are done on these are different than the ones that are done on these. So these are so-called S-plan objectives, and that means that they have got like pretty good correction. But these ones, which I don't think you can read on camera, they're actually apochromatic objectives. Have you heard that term by chance?
No, I have not.
So yeah, there's the terms are, geez, what's it called? Achromatic correction. And then I don't know, there's like one more term. And then apochromatic basically means perfectly corrected. And what that means is these don't need that eyepiece level correction. And in fact, if you do have the eyepiece here, it might even mess up the correction a little bit that you do down here. And with that in mind, what the issue is this lens, which came from a microscope distributor, has no corrections applied. And it means that it's designed for these objectives and not these. And if everything is correctly set up, it should produce a good quality image. Are you with me so far?
Yes.
Okay. Now, much to my chagrin, though, I was doing some imaging the other day, and the image was actually quite distorted. The biggest distortion that I saw was so-called barrel distortion. Do you know what barrel distortion is, or like pincushion?
Yeah, the edges of the image kind of warp a little bit.
Yes. And in kind of a circular manner. And so what that suggests to me is, one of the errors could be that you need to tilt your microscope. But in this case, it looked like it was actually something else. And I did a little bit of research, and it turns out, man, I'm trying to think if I have the original thing here. I can pan to this other microscope over here. Let's see, because too many microscopes. So you can see there's this little, what do you call it, beige little ring thing on top, right?
Yes.
And the issue is that the camera sits on that quite high. So normally, just like on this other microscope, maybe I can move this out of the way. This camera would fit into this right here. And this is a bit high up. And when it is in this configuration, it turns out that even if you try to adjust the height of this camera a little bit to be in focus to this, it is impossible to make it both the eyepieces in focus and the camera in focus at the same time. And I researched that a little bit a while back, and I thought that that was just an inconvenience, but I started reading that apparently if these two aren't at the same focal distance, you start running into some imperfections in the lenses, and it actually messes up your microscope images in the way that I was observing.
The images from the digital camera, or actually from the eyepiece as well?
I would say primarily through the digital camera. I think that there is some imperfections that I'm also seeing through the eyepieces, but that is more due to the eyepieces were matched to overcorrect the lenses that I was using on the microscope. But overall, the images through the eyepiece were much higher quality than the images that I got through the camera.
Okay, so how did you go about fixing this?
Yeah, so I took this little bit out on here, and I just started inserting washers on here to play around with this camera height. And I found out that if I were to actually sink this camera down a little bit, I could get these eyepieces in focus with the camera. And I tested this out in this very shaky, like washer stacked setup. And I found out that yes, the camera image quality improved drastically once I did that. Except washers aren't really good, like stacked haphazardly for precision imaging, right? Yeah,
The ultimate hacker microscope.
That's right. Yeah, but hacker, but not good for precision. So this is where you stepped in, right? And do you remember kind of what we did at that point?
Yeah, so you gave me a custom part at the particular height that I 3D printed for you.
That's right. And that's how we went from that guy over there to this one over here. And if you look, this one's actually quite a bit shorter than the one over there. And then from that, what I did, let's take this camera back, and let's see if we can get this on there. It's a little bit hard to see, but where it says, like 5, I don't know, it says 5 millimeters. So see that there. Right above that, you actually can rotate this, and there's a very fine screw thread here, and I can do very fine adjustment on the distance between this lens and this camera. And using your bracket then, I was able to get coarse positioning and then do fine adjustments with this offset here. And by doing that then, I was able to match this pretty well to what should be the correct height or the tube length, or I don't know exactly what they call it for this type of microscope, but getting that distance anyway is correct to produce the best quality images.
What kind of margin do you have, like in millimeters or, less to get that height correct?
Well, I don't have a good concept of how critical it is doing the correction here versus here. But ultimately, it's kind of an image quality thing, right? If you get this wrong, the image is not going to be terrible. It's just going to be subpar. So it's also like, do you want the absolute best image quality? And that's very subjective as well. So without having a very formal way to evaluate that, it's a little bit hard to say.
Okay.
Yeah. But anyways, yeah. So now putting this in here, the image quality, I would say overall is much better. I would also say that this new adapter is a bit stiffer, so I'm able to put the camera in here, and it holds its position a little bit better, which is nice, because sometimes this camera would drift around in the old adapter. Aside from that, though, what I do need to do next from a final calibration is these stages down here have a small offset. If you might be able to see right here, these little bits of aluminum foil, that is squaring up these stages to the imaging plane up here. And this is actually the major source of aberration now, is this is not perfectly squared up. Because I started calibrating it with these shims here, but then I realized that there was this other aberration that was causing so many issues that I decided I had to fix that first before doing any more tuning over here.
And how do you plan on fixing that?
It's a kind of a labor-intensive process. The basic idea is I take all of this off here and I put a very flat object on the stage down here. Silicon wafers seem to work really well. They seem to be very precisely flat. And I'll just visually look at the image field and insert shims in here until it looks flat.
Is this something that you do, or you have to do very often, this calibration of the plane, or is it usually, you do it once and it pretty much stays
You do it
set?
once. It's theoretically possible if you start adding more objectives here that change the balance on the microscope, it might offset it to make it not calibrate the same. This frame, though, is pretty stiff. And I think I found that generally speaking, when I add objectives, it'll knock the focus out a little bit, but not so much that I actually lose the calibration. So it doesn't seem too sensitive. I
Okay,
did.
so you,
I did. Sorry, why don't you go?
So no, I was wondering if this was like a one-time thing, or whether, if you had a stage with like adjustment screws or something, if it would make your life easier. But I guess it's not as common.
Yeah, it's difficult. There are some screws down here, which I could maybe get a little bit closer. Let's just do this as an experiment. Yeah, so you can see those screws there. I did consider putting something there to make that more adjustable, but it would have been tricky and it would have ultimately impacted the end stability. So I didn't put a lot of thought into it. It is worth mentioning, though, the reason why this all started in the first place is there are screws that go from these stages to these bases here, and one of those stripped out, and that messed up this calibration here. And so that's kind of what started this whole calibration process. So I did have to rerun that calibration because this got messed up, but that was kind of an anomaly. It wasn't part of normal operations.
Okay, very cool. And how have your results been? Did this actually help a lot? Is the image quality pretty decent now?
Oh, for sure. It's definitely a lot better than it was in the past. I'm imaging a bunch of chips right now, and hopefully you'll see some of those results in the near future.
Ah, great. Yeah, definitely looking forward to it.
Well, I think this may be a good place to stop unless you have anything else to add.
You know what I see there?
What is that?
A little lightsaber.
Oh, yes. So one of the things I still have to do is I have this UV light. And what this basically is for is I need to clean this microscope a bit. And so I'm putting this in here to check for dirt and stuff on the optics. And maybe that can be a subject of a future video on kind of that process to go through there.
Sounds good.
Okay. Well, thanks for listening then. See if there are any questions. Did you by chance see any?
No, that was a technical difficulty at the start of the show. I had the stream running at the same time and it was making noise, so I had to shut it down.
I see. Okay. Well, thanks for listening then, and until next week.
Yeah. Have a
Bye.
good week.